Then we will be looking into uncertainty, significant figures, and the values that are your actual values. It's this column, first one. Definitely we are keen. 5 centimeter when you change, it becomes 0.05 meters. Yes. And then what was your next one? Is it 10 centimeters?
Yeah.
So that becomes this. Okay. Next is your 15. So plus and minus here, what do you think should be the number? 0.01. Okay. That's what you will write your uncertainty there. 0.01. The number that I had given as 1 centimeter, I can't recall. I did it in a hurry while teaching another class. It's 0.01 meter uncertainty. Okay. Yes?
On the thing it says 0.1 centimeter, so wouldn't that make it 0.001?
Yes. Good question. Now, yes, I know ideally you should look for the smallest digit on the equipment, whatever equipment you are using for measuring. But for this particular one, when you are rounding it to, look for the last digit. If you want to do 0.001, this, in that case, make sure you do this. Okay. If you are not doing this, then it should be 0.01. Remember that. Okay. Next you have is 4 or 5 columns of, is it 10 oscillation? Okay. Whatever the number is, 4 significant figure, whatever is written, do not bother. Just leave them as it is, or whatever number you get, write them as it is in these 4 or 5 reading. We are not going to bother about significant figures in this column. This is your important data, this is your raw data. We are not interested about significant figures. Next you do average, but this average with uncertainty is still your raw data because this is for 10 oscillations. Okay, so when you do the uncertainties here, suppose you get uncertainty as 0.35. Please just leave it as 0.35. Do not try to round it here in this column. When you change it to period, 1 oscillation, plus and minus 0.02 seconds, and here you had plus and minus 0.2 seconds. This time when you've got, suppose here your period was 4.4, you do it to 0.44 plus and minus 0.04, and then you round it, please. Okay, so 1, 2, 1, 2, that's okay. This is the column we will be looking into. This is the column we will be looking into. The last column which we will be looking into is, you will work the transform data. What will happen to L here? This is the broken length, which is B. What are we doing to the length here? Square root B. So this is square root B plus and minus uncertainty in B. While you are doing this, you're not just doing the square root of 0.050, but you are doing the square root of 0.05 plus and minus 0.001. This is very important column for M. When we are marking your uncertainties, if you can look at this grid, and you all are going to get a copy of this, or I think what I'll do is I'll put this on Moodle. Okay. This is a general marking schedule for this achievement standard. Okay. Now in this one, if you have a look, which one is it? I think it is this. Marking schedule. Okay. Uncertainties. Can you see the uncertainty middle merit box? Uncertainty in independent variable are accurately processed. Above that is uncertainty of transformed independent variables are identified as insignificant in discussion. So you do speak about that. Uncertainty for dependent variable are calculated and processed correctly. And uncertainty in transformed data is calculated using percentage uncertainty. In fact, that's needed for achieve. This calculation is required for achieve. That you change this to percentage. How many of you are confident in doing this properly?
We have to put plus or minus the uncertainty. We have to square root the uncertainty as well.
Yes.
So would your answer be that?
Yeah. How many of you are okay in changing this?
That's the, yeah.
You are fine? Do you want me to go over this? Okay. So what you do is 0.050 plus and minus 0.001. If suppose that's the value you are using, square root equation is percentage uncertainty is absolute uncertainty divided by real value times 100. Okay, this is your absolute uncertainty, this is your real value. Okay, so you first work out the percentage uncertainty. And percentage uncertainty is, hey guys, if you're not interested, can you work quietly for a minute? It will be very helpful for others. Percentage uncertainty is 0.001 divided by 0.050 times 100. And let's do quick calculation for this. 0.001 divided by 0.05 times 100, 2%. Answer is 2%. And what do we do next? We will write square root 0.05 plus and minus 2%. And now work out the square root of 0.05 square root, which is 20.236, or just round it to this number, plus and minus 2%. And what do we do with 2% when it is square root? What is the rule? Half. So times that by half. So answer becomes 0.24 plus and minus 1%. But that's not what you're writing in the table. You will change it back to absolute uncertainty. And what do we do to change it? Please, others are listening. And it does disturb me. Okay, so when you change it back to the absolute uncertainty, same equation you're rearranging, and the equation becomes, what I'll do is I'll make this screen clear for a minute. Okay. Absolute uncertainty is percentage uncertainty times real value divided by 100. So your percentage uncertainty is 1 times 0.224 divided by 100. And what do we get? 0.224 divided by 100. 0.0023. So what do you write in the table, Dave? when you write this, square root b plus and minus change in b is 0.223 plus and minus 0.002. We don't write 3 because we are finally writing uncertainty in one significant figures, and these numbers 3 after decimal places. Clear? Same way you will do for all of them. The number is going to be different because each time your length value is different. Okay, and that is a must for achieve, simple achieve. Yep.
So if you have any uncertainty, do you always put the ones in the different?
Yeah. Yeah. And that many decimal places you change for the other value. Any question on this? Yep.
Wait, what exactly do you do with this value? Like afterwards? Do you just plot it or?
We will plot just the square root b, not uncertainty. But in case your vertical bars are small, then you will use this uncertainty to draw horizontal bars. You might have to use it. Initially, you just show that you have an understanding how to use uncertainty in square root or power form or whatever. Yes?
In this, it says if A is proportional to the square root, then you have the percentage error. I'm confused.
You just want to have a shape down.
Yeah. And then it drew.
Yeah, square root you do half a percentage. That's what I've done. There was 2 and I've done half of that percentage, which is 1. I've done on the top.
Okay. Sorry.
Which ones are your 1, 2, 3, 4, 5?